Hi everyone, welcome back to my channel Vertex MrRoy. Exercise 18.1, the differentiation of sine, cos and tan. The differentiation of sine x is, before starting this exercise, we should know what is the differentiation of sine x. The sine x differentiation is cos x. And the differentiation of cos x is minus sine x. And the differentiation of tan x is sec square x. So we should know these differentiation of sine, cos and tan trigonometrical functions. Then we can start our exercise. But before that, I would like to give one very most important example. The first thing this here, when we differentiate only sine with 2x, then please remember we have to do two steps here. We have to do two steps means first we differentiate like the sine 2x. And second time, we have to also differentiate the angle, the 2x. So what's the result? The sine 2x will become cos 2x. There will be no effect on the angle. And this 2x will become only 2. So 2 will become the coefficient of cos. This is the way. Third most important example, this is here. Like this will be same like when angle with cos 2x or cos 3x or cos 5x or 10x, like 3x for whatever, we have to also apply the differentiation on the angle. This is the most important example here when we have like sine cube and 5x. This is the most important example. Even you can write in the bracket the angle is 5x plus 2. So in this situation, you have to apply the differentiation in three steps. Number one, you have to differentiate with power. Like this is, remember the sine cube means the sine 5x plus 2 is whole cube. Remember, because sine squared x is equals to sine x whole square. Because this square is not on the angle. Okay. So first we apply like with the power. This is first step. Second step, without power, like only sine on without cube. And third is with angle only. So it means we have to apply the differentiation in three steps: with power, without power, and the angle. When you apply the differentiation here with power, 3 will become the coefficient, and the power is reduced by 1, so is 2. Multiply by a differentiation of sine. Like here, we will not change sign, we apply the power. Then here we change the sign, will become the cos. Cos with the complete angle 5x plus 2. Multiply by, now the 5x plus 2 differentiation is only 5. So when we simplify 5 and 3 is coming 15 sine square 5x plus 2 into cos 5x plus 2, and that's we have done. So this is the basic explanation for exercise 18.1 to start. So let's start with the question number 1. Question number 1, 18.1. So first part, we need to differentiate d upon dx. Normally we should write actually in the exam, and sometimes we can do it directly. So this is the differentiation of 4. Like normally just remember one thing, we never differentiate the coefficient. Never differentiate the coefficient. Like 4 will remain 4, and the differentiation of sine is cos x, and minus 3's differentiation is 0. So right answer is only this part. When you move to b part, the x square differentiation, when we write here directly d upon dx here, so differentiation of x squared is 2x minus 5 differentiation. Like normally we do not apply the differentiation on the constant term. So cos x differentiation is minus sin x. So when you simplify, it's coming 2x minus minus is plus 5 sin x. So we have done. Next is c part. In c part, 2 sin x differentiation, when you like write here d upon dx completely. So the differentiation of 2 sine x is 2 cos x, and differentiation of cos x is minus sine x. So it will become minus 3 sine x, and we have done it. Part D. 4x square differentiation, when we apply the differentiation here, like in this bracket, so it will become 4 times 2 is 8x. 10 differentiation is sec square. So we'll write plus 3 sec square x, and we have done it. This is the way we have done question number 1. In question number 2, we have to use the product law, the formula, when we have two things. So what we can do in the A part is you have to suppose like here, u is x squared, so u prime will be 2x. V is cos x, so v prime will be minus sin x. V prime means differentiation of cos is v prime, dv upon dx. So now, this is u and this is v. So we apply like what's the formula when we differentiate d upon dx with uv? We write u v prime minus v u prime. So u is x squared and v prime is minus sin x, minus v is cos x, and u prime is 2x. Now just we need to simplify, is coming minus x squared sin x and minus 2x cos x. Please just note just one thing very important, that whenever you have cos 3x, like this angle, angles are never affected by anything. 2 minus 2 multiply plus divide plus, like angles are never affected by anything. Here that's why 2x is the coefficient of. So here we apply the same u and v, and this is u upon v. I would like to do d part. U is 1 minus 2 sin x. So the u prime will be 0, like differentiation of 1 is 0, minus 2, and sine is cos, and v is cos x, and v prime is negative sine x. Now just when we differentiate, when we apply the question rule, u upon v, please remember one thing. I just want to say one thing about this formula, that v squared, like v square in the denominator, v is here u prime minus u and v prime. Actually what we have v in the circle, that you can see. If you forgot, please, this is very important, we cannot change here sign. We always write v here, not u v prime, always v, because the minus sign is there. So in circle we have v. So v is cos x, and u prime is minus 2 cos x. Then we have minus u is 1 minus 2 sin x, and v prime is minus sin x, divided by, like v squared is cos x whole squared. Just we need to simplify now. Like normally I advise my student to take common here, but just let's see. 2 cos squared minus this minus and minus is plus. I multiply sine with 1 and sine with this. Sine with 1 is only sin x. This minus minus plus plus minus is minus 2, and this is coming 2 sine square x. If I am not wrong, you can see this, okay? Then we have cos squared. We can write whole square is cos squared. Here we can do one thing I would like to do here now. From this sin x, I'm writing sin x first. And this cos square and sin x, I'm taking minus 2 common. So it's becoming cos square x plus sin square x divided by, like this is like we have to simplify, like at the end. This is equals to, this part is equals to 1, as we know trigonometrical identity. This is equals to 1. So what we can do, we can write sin x minus 2 times 1, and then here is cos square, and finally you can write the sin x minus 2 divided by cos square x, and we have done question number